Good afternoon, one and all present over here. I take immense pleasure to take over and will give a welcome note to him. Welcome, sir.
Yes, hello, am I audible?
Yes, sir.
Yes, I welcome Ar.Kosi Emmanuel, sir. Thank you for accepting. Thank you for accepting our invite. It's a great pleasure indeed. I posted, when I to my colleagues, friends, PhD colleagues, very much to watch your session, sir. It was a great inspire. We are expecting that great inspiring moment to be happen soon, and we see the family as always thanking you, sir, for accepting our invitation and sharing your knowledge to our students and other college students was going to participate and other participants thanking one and all here and the faculty members and the students. I'm thanking in this last but not least, I'm thanking my management sir immediately accepting this ideology of creating online webinars, workshops and guest lectures. Coach Chairman sir and Director sir and Dean END and Dean KTR thanking for supporting us. Seed family will achieve a lot with support architects. Thank you, sir. Thank you all. And without any further delay, I am handing over the mic to coordinator.
I now request Architect Pooja to give the introductory note about the architect.
A very good morning, everyone. It gives me privilege to welcome Architect Kosi Emmanuel, who graduated with Bachelor of Science in Architecture from Afghan, Nigeria, and has procured the Masters of Architecture degree from SRM IST Chennai. Currently, he is a lecturer at Department of Architecture, Namdi, Azikwe University, Awka in Nigeria. Architect Kosi is licensed architect and senior partner at Geometric Consultant and Builders Limited. He is also the founder of Architecture Web Courses, CADWrite Global Resources, and Academy for Sustainable Technical and Business Support. Architect Kosi is an author of various articles, papers, and books like 48 Laws of Architectural Consulting, Learning to be an Architect, and Introduction to Green Building for Architects, to name a few. We are glad to have you, sir. I now request you to take over for the presentation. Thank you.
Thank you very much for having me. It's a great honor to be here. And I want to say that I'm highly elated at the opportunity to share whatever I have learned in my very short career with the participants. Before I go into my presentation, I want to thank the technical team that have arranged this wonderful opportunity for us to learn. I want to say thank you to you, and I want to say thank you also to the participants who have come in from all regions of the world, from Nigeria, from India, from anywhere you've connected. I want to welcome you. Also, I want to let you know that we will all come out of this lockdown stronger. Okay, so having said that, I'm going to be talking about a topic which is titled Bioclimatic Skyscrapers. Before I go into the in-depth details about what bioclimatism is all about, I want to do a brief introduction about skyscrapers. Of course, skyscrapers are a Western design form which we have borrowed all over the world, and it comes with different challenges, as we have known. It comes with a lot of technical requirements. It is not like the very conventional kind of building form which we are used to, which is what brings us to the topic of today, bioclimatic skyscrapers. If you would permit me, I would like to share my screen with you so that we can move ahead quickly. I'm going to be introducing to you a topic which I've titled Bioclimatic Skyscrapers. We're going to be doing a brief literature review and case studies as well. Just as a little background, My name is Ar.Kosi Emmanuel. I'm an architect from Nigeria and a university lecturer from Nnamdi University, Oka, Nigeria. So the presentation today is going to be in this format. First, we're going to discuss what skyscrapers really are. Then we're going to look briefly into the origin and development of skyscrapers, as well as the socio-economic and environmental benefits and challenges. Then we're going to consider an invention by a very notable architect, Kenyan. We're going to look at the philosophies and theories that he had theorized as regards skyscrapers globally. Then we're going to delve into the case studies of bioclimatic skyscrapers. A number of them have been done around the world. We cannot review them. We are going to try as much to strike up your interest. Then we're the general skyscraper versus the bioclimatic skyscraper. Then we're going to have all right. Can you all hear me clearly?
Yes, sir, we can hear you. Yes, sir, clearly. Can we have your presentation at full screen, sir?
Okay, better now. All right. So, continuously has a building that has over to 20 floors in the 8th. The issue are there are nobody which is responsible for setting standards regards what you can and what you cannot skyscraper. And this body statistics. You will measure the height with regards to the architectural height, or it will refer to the assault with respect to the height or it also refer to IC. It is not be that tall. So there are a number of also factors that influence what you can also discuss it in form of its process. Means a building pitch is a little bit on the taller, on the slimmer side compared to another one which is a little bit on the horizontal spread. Could very the building will be seen per se if it has tried to increase and buy technologies that are associated with technologies, technologies, and all that. So, bearing this in mind, it is important for one to understand exactly what is the context of discussion. There is generally no specific definition for what you can say is because it's contextual, like I've explained. But what the Council for Tall Building and Urban Heritage are trying to do is to give so one base what we're calling that one is. So if you understand that, you can see from your screen that actually Khalifa from the see it shows you can see some of these buildings having some specs, some antenna or some pole at the top. So, but that is not the architectural top. The architectural top refers to the last floor, the height of it. Like buildings have antenna, some buildings have monumental objects mounted above them for whatever reasons. So, buildings in this, you measure from the street level to the islands, whether it's an level, the architectural 310 meters. If it has, if you measure using this criteria, if it has an antenna or a pole sticking out from the roof, if you measure the same building, you can have two different heights. So whenever someone so have to ask what you're using. Are you measuring from the height of the occupied floor? Or are you measuring to the height of the tip? Or are you measuring to whatever other metric the person has? Having said that, let us look at how it has come about as a big touch. Didn't always build tall, always dwelled in building the sky. What helped it? You can see it was around building. It was regarded as the world's first skyscraper. It used a novel kind of steel load-bearing frame, which eventually became the standard worldwide. And if you fast forward to about 100 years more later, you can see to your right there, the One World Trade Center. You can see how the later versions of the skyscrapers kept becoming modified as technology advanced. So technology is one factor that has influenced the man's seeking after construction of tall buildings. Because if you do not have the technology, I mean, if you cannot construct, if you do not have the technology like invention of steel and all that, you realize that the structure cannot go that tall into the sky. So if you look at another scenario in Europe, Europe didn't actually catch earlier as fast as America. America set the pace when it regards it was they invented the skyscraper typology. And then elsewhere in Europe, you can see Europe didn't catch on very fast. You can see it took them up till 1950s before they even began to experiment with buildings over 100 meters. on the screen, you can see the university in Moscow is in Europe, and over there you can see the Palace of Versailles in Warsaw. And there are so many other examples like that. So Europe was more interested in preserving their cultural heritage. They weren't going to start discarding their, Europe had a long history of colonization. They colonized almost the whole world at some point. So, they had edifices, they had monuments that to them had more cultural heritage and significance compared were very eager to show their power, authority, and conquest and innovation by building taller and taller and taller and taller into the sky. So that is the brief history of skyscrapers, the beginning, how it started, and what encouraged it. I mentioned technology encouraged it. Also, urban urbanization has played a factor because more and more people kept migrating over the centuries, over the decades, from the rural areas to centers, and land became a scarce commodity, as a matter of fact, because to step horizontally, you need to acquire more land, but the skyscraper to use the area of land to achieve more density, even though it comes with its own drawbacks as well. So you can see historical development by height. You can see from less than 100 meters, the buildings kept getting taller, kept getting taller, kept getting taller, kept getting taller. Century after century kept getting taller until where we are today, the Burj Khalifa in Dubai. So this screen shows incremental change in the history of the world's tallest buildings. Historically, benefit, of course, associated with high-rise building. Of course, like they say, there are two sides to every coin. So then I'm going to also let you know about the drawbacks. So first of all, you talk about and the fact that the spread. So if you don't want to acquire more properties, invest in and your building better. You find that you also have unstructured scenic views. So you then find a tower, a watch. You tend to is living on a one-story or two-story or at most four-story residential building. So that is what you can also call as a buildings, tall buildings. I already mentioned the land saving benefits. Then you also talk about the mixed use advantages. It brings cheaper tenancy costs due to shared facilities. Like I already said, a building which is tall can combine usage. So if you are going to do a shopping mall there, then an office building there, then a residential building there in three different parcels of land. Now you have one parcel of land and you're combining the use, mixed use. You save more money and the costs are maybe cheaper, depends on the location. So we also talk about the symbol using, tall buildings became a symbol of authority and technological advancement. Like I mentioned, our folks, our counterparts in the in America, used tall buildings to enforce their authority as a world power or as an emerging world power at the time, and also to show that they had the technology to achieve it. So it's a means of showing off, if you can say that. So you can also talk about high-rise buildings as they provide more free space for green plantations on the ground. So that you take a small area and build tall, and you leave the rest of the site for your plantation and also parking spaces or public events. It also improves social economic value of the surrounding properties. So if you have ever noticed, the moment, if you have a rural village, a rural area where no one has ever, no much business activity, economic activities going on there, the introduction of a school or a hospital usually attracts economic activity and improve social interaction because people will come and set up businesses around that school to support the school and to feed off from its students and staff. So in this case, high-rise buildings provide a kind of economic boost because all the other properties around it will automatically increase in value because, I mean, it's close to the World Trade Center. So you can discuss the increment in value. Then you talk about less noise. You know, the higher you go, you leave the noise on the ground. The noise from transportation, human noise, and industrial activities and all that, you leave them here. And you are in your safe haven. The noise is clear, apart from the wind, the noise from the wind. And then you have this feeling of exclusive living. You can see everybody living on top of the world, literally. So these are a few benefits that you can derive from building high-rise buildings. And now we're going to look at the challenges associated with high-rise buildings. Like I say, every coin has two sides. You cannot throw away the good one side, the side that has the face of the politician, and take the side that has the number of the currency. You cannot do that. So every coin has two sides. High-rise buildings provide us with immense benefits, but they also pose a lot of challenges, which we are going to summarize here. You can see a study conducted by the U.S. Department of Energy, and you can see that they studied a number of high-rise buildings, and they came up with made this chart that we have here that shows us how much energy is consumed by high-rise buildings. And you can see that the equipment energy consumes 31%, fans, pumps, and control energy consumes 6%, the water systems energy consumes 1%, and heating and cooling energy consumes 33%, while lighting energy consumes 29%. So from this, you can see clearly that high-rise buildings have more demand for heating and cooling as against the conventional type of building. It also is resource intensive. It's resource intensive due to excessive scale and complexity of design and urbanization, insecurity of resources are key challenges. A wrong design strategy can lead to more energy consumption. A wrong design strategy. This brings us to why we have to do bioclimatic skyscrapers. So we're not going to throw away the building typology because of the challenges it poses, but we're going to adapt, we're going to try to imbibe bioclimatic or what you can just simply call as green building principles to this building typology. Earlier, when skyscrapers became a force to reckon in the building industry, became welcomed as it used to be more or less a box, a glass box, what you can call, one researcher called it and was everywhere in the world. You want to do a skyscraper, do a box. You shut off the environment and you do your own thing internally. You cool internally or you heat internally. You ventilate with mechanical means, and immediate environment. So it's like you're in a glass box. But that conventional style has been proven to be problematic. From the metric you can see here, you can see that it's costing us more energy to heat or cool these buildings. Depends on the climate where they are located in the cooler areas. You talk about heating. You're located in the tropical areas. You talk about cooling. So one of the challenges then. How do you take water up to a person who is living in the 50th floor of a high-rise building? The water is there, groundwater is there. To ask the heavens for water. So you need to have a technology that gets you the water from the ground and pumps it up to you. And technology costs energy, and energy costs money, and also destroys the environment. So we also talk about, I already mentioned the heavy energy and heat supply requirements. Then also wind pressure. You know, we all know that the wind pressure, atmospheric pressure, humidity, temperature at the ground is more stable. Stratified, and you have different layers.
All of a sudden, okay, okay, I'll go. நானே வந்து வாலண்டியரா என்னை யாரும் மோசமா பண்ண யாரையும் கூட கேட்கல. Okay, I felt எங்க அம்மா சொன்னாங்க நான் வந்துட்டேன் அவ்வளவுதான்.
Sorry for that, but there's some. I request all the participants to keep themselves on mute. I'm sorry, Kosi sir, we can continue.
So I was saying that the atmosphere that we live in as human beings, as living organisms, is stratified. And the different layers have different provisions for wind, atmospheric pressure, humidity, and all. So as you go into the atmosphere, the wind pressures are higher because there are less obstructions. So we have seen buildings past that were affected due to the design not providing for wind flexibility. So we also talk about reliance on technology, safety. How do you 100-story building on your apartment on the ground? Because some of your 100 stories above before you ground. So it's a challenge to be considered. Then also you talk about the need high skill ones and delve into. You need some special training and experience before you delve into this field. That also attracts some costs implication. So having said that, the factors that encourage high-rise development, then we can now bioclimatism, which is simply the principle of green building. So bio, which is life, and climate. Area. We are life. We buildings to be sustainable in the long run, considering as a principle of bioclimatism. It's a that aims at building surroundings and local so I'm going to demonstrate of what we can take back to research examples of that. So we have one feature. It's located in Eminent Architects. So you see there's a four high-rise buildings, defines the green heart, a public space extending over several stories. Of tropical flora. The core concept of the central space, the green heart, as we can see in the center, the image in the center shows it. And the interaction between the geometry of the buildings and the garden facilitates natural ventilation and generates an agreeable microclimate. So four high-rise buildings are constructed in a place, and they have a center, which is what is called the green heart. The center has a lot of flora. Flora means plants. So a lot of tropical plants have been done in the center, and you know, plants have this long-standing relationship with humans because we need them as well as they need us. And one key feature of bioclimatic skyscrapers is the ability of the designer to take the plants up into the sky, or at most whatever level you can, so that the symbiotic relationship can continue between the building occupants and the natural plants. We, of course, know that plants take in CO2, carbon dioxide, and they emit oxygen, while we need the oxygen and we emit CO2. What a lovely relationship. So when you are constructing a building 200 meters into the sky, where is your friend, the plant? You have left him on the ground. So you need to take him up there too, so that your lovely relationship can continue. So that is what these guys have done. They have created a center to make sure it continues. This is another example by Kenyan. I forgot to introduce to you the very notable architect who has pioneered the principle of bioclimatism. He has done extensive research work in this area. He holds a doctorate degree in architecture, and his work traverses most of the continents. He has done skyscrapers in Asia, in America, in Europe, and in every project of his, he preaches the same doctrine: bioclimatism, sustainable skyscrapers, especially in the tropics. Most of his has been in the tropics. He has a career spanning more than 40 years in the industry. He has written a lot of publications, a lot of books on this same subject. In fact, as far as I'm concerned, he is the patriarch of bioclimatic skyscrapers. So most of the examples here are designed by him. In this case, this is the Messiniaga Tower. It's there in Malaysia. It was completed in 1994. It also won the Aga Khan Award for Architecture. A few of the salient features which he included in this particular project is the vertical landscaping. Also the spiraling sky garden. As you can see in this image, the garden seems to be spiraling up to the roof of the building. Like I mentioned to you, that you need to devise a means to take your friend, the plants, up with you if you are really planning to be sustained up there. So that is what this man has done. Then he also introduced a rooftop swimming pool and recreational center and cafeteria located at the highest floors. So if you look here, you can see how he also, the image on your left, by the left, you can see some recesses. It's not a box, not a glass box. I mentioned the glass box ideology earlier, you can see that this is not a box. He has allowed some recesses along the facade to make sure that natural light as well as ventilation comes in at organized intervals, not arbitrarily. So that is what you mean when you say bioclimatic orientation. He has studied about the wind direction, the sun direction, the solar path as well, so that you position your building in such a way that it maximizes the solar elements of light and energy. Then you talk about the, already mentioned solar shading, optimal positioning of services for, and it maximizes natural lighting and ventilation. Here is the Edith Tower. This tower is located in Victoria, Singapore. The client is the Urban Redevelopment Authority of Singapore. It's again designed by our friend and patriarch, architect Ken Yan. It has a number of 26 stories into the sky. So if a story, suppose we use the convention of 3 meters, or at most 2.7 meters, multiplied by 26 stories, you see you're very far off the ground. So you can see from this image how he has been able to again take up the ecological elements of flora into the facade of the building, up the facade of the building. It's a very interesting one to look at, and it's also a beautiful rendition here. You can see that it's actually very beautiful to do bioclimatic skyscrapers as against hot boxes called modern. So we talk about the salient features here are water recycling, sewage recycling, solar energy use, building materials recycling and reuse, solid waste recycle, and mixed mode ventilation. Mixed mode ventilation is a kind of ventilation concept that heating or cooling technologies which consume more energy and are not very sustainable in the long run. So the next slide also continues to explain what nice features this particular tower has incorporated. It has sky courts, convertible for future office use. It has removable partitions. It has removable floors. It also features mechanical jointing of materials, flexible interior spaces. And then it also features the high-level bridge linkages added to connect the neighboring buildings for greater connectivity, which is a lovely feature. I really like this because if I know that I do not ground zero before I can connect to the next building, it's lovely because it saves me time. Then you talk landscape to upward from the street level, as you can see in the image, and well-planted facades and vegetated terraces. Very beautiful site. Then, next building here is the in building. I love this building. I love the facade a lot because they have done something very unique with it. Line architect and Dimitri Roussel. This building won the BREEAM Very Good Award. We all know about the energy rating systems that try to set the standards for what buildings can be called green and what buildings can be called not so green. So if you're an architect and if you design to meet any of these standards, you win points, you earn points. There are a number of energy rating systems used across the world by different regions. We have the leadership in energy and environmental design, which is LEED, the most popular all over the world. We have BREEAM, which is this one. And each of these, I think you have the red star for China. Systems try to set metrics, try to set standards so you can win in good very good, gold, platinum, whatever, according to how sustainable goals you have in mind in your design and category for design. Even if the building can also just by displaying your design and showing that design built this way. So back to our case study here, we have the inside-out office building. It's called building because the designers tried to do an the interior and the exterior. So they allow nature to come in. You know, in some areas it has the it interlaced the space with the exterior space. So instead of the usual having the building at one corner or in the center, they have the vertical elevation systems, the stairs along the facade, with which they had enough, which gave them enough space for plantings. They have concrete pots where they have made very, very surviving you can see it, which again is our friend pointers as usual. So behind workplace well-being by prioritizing outdoor spaces and greenery, workstations on the side, like I mentioned, the building completely open. It's not locked up. If you are an occupant of this building, you feel as one with your immediate environment. Light, you know, you feel like even though the building is not try to bring a concept with the facade and also try to carry our plant friends along. The circulation passage is easier to escape in terms of fire hazard, and then you have long terraces with each level steps to maximize its exposure to natural light. And the terraces have gardens, like I mentioned. So about the solar star, the next case study is on the solar star. This is a designed by that is the business name of Kenyan. Is there in North Singapore? Operation and also won the BCA Green Mark, the platinum rating. The platinum rating is the highest point in the green rating system. So you see, it is more illustrated here. You can see it has roof gardens, which is what salient features this building has incorporated. You can see that somewhere here, the architects have tried to introduce a shaft, a solar shaft, what they call a solar shaft. They have studied the sun part of the sun over this building, and they have provided a shaft so that at every point in time, the direct sunshine or what you can call daylight from the environment can get into the part of the building, which is a lovely feature, as against trying to provide daylight, trying to provide light completely artificially. So they have done a very wonderful one there. You can see the roof gardens, roof gardens, continuous vertical landscaping, 1.5 meter urban ecosystem. You can see the naturally ventilated David's atrium. Got an atrium, naturally ventilated, and it has a solar shaft, like I've mentioned. It also has a climate responsive solar shaded facade. It also has sky terraces on which they have made plants. Then it has the veranda way, semi-enclosed tropical walkways, and eco-cell and rainwater harvest. Rainwater harvesting is a very vital feature when it comes to sustainable development. It's a concept where you can, trap your rainwater. The rainwater that comes in contact with your building you can devise a technology to trap it, treat the building. So this reduces your need to buy or source for clean water because you can make your own clean water and recycle it as well. So this is a very wonderful example of Kenyan's relentless efforts towards bioclimatism, as we have mentioned. The Solaris Towers was designed to create a completely ecological site instead of replacing natural habitat with a built environment. The design sought to create a maximum amount of habitable green spaces, which came up with this very beautiful facade on the screen. So it's a good one. Then we can also consider the Spy Edge Tower. The Spy Edge Tower is located in Haryana, India. It has a total number of 21 floors, again by a veteran, Kenyan, and the building has won India's first, won an award as India's first bioclimatic skyscraper. You can see how the greenery is brought up to the roof by a series of vertical landscaping elements, very beautiful facade massing, you can say, a series of sky terraces and rainwater collection mechanism, treatment and storage for circulation. How the flora, the plants are begin to rise and find their way all the way to the roof of the building. It is a very dramatic more beginning with myself, this kind of concept while designing. Am I able to come in? Can you hear me clearly?
Yes, we can hear you.
So, features include I already mentioned the rainwater. Anyone there trying?
No, sir, we are here, sir. We are listening.
Okay, thank you. So again, in Singapore, Kenya has tried to do National Library House, National Library, which he used to practicalize some of his theories. Like I told you, he started his career, and he has written a lot of books and articles and publications talking about why and how architects could imbibe bioclimatism in their work. And he has also taken the step forward to do what he preaches. So many times, even in our examinations, we write these things in our exams and we pass, but when we get a commission to design a project or to handle a project, we fall into the temptation of doing the conventional things that other people who do not have the knowledge that we have do on a daily basis. Maybe because of pressure from clients, maybe because of shortage of funds, or for whatever reason. But this is one architect who is an academician. He has his doctorate degree, and he has also practicalized most of what he has preached. So the atrium of this building, which the architect referred to as the internal suite, is the main focal point of the whole project.
Sir, looks like we lost your connection. Are you there?
In building. So when we talk about bioclimatic design, like already mentioned, or more or less the same thing, only applied to skyscrapers this time. So in summary, the same principles should guide your entire designs. So if you're doing a low rise, you're doing a medium rise, or you're doing a high rise, you should try to principles of material efficiency, energy efficiency. All these are very vast fields. Energy efficiency alone, you can discuss about mechanical versus passive cooling. You can discuss about daylighting. You can get acquainted with the and buy. These things are most times easy to integrate if only we can stand up for them. If only we can stand up for them. Sometime in a project, I was a project architect. We were in a meeting, a site meeting, progress meeting, and we had this issue. The roof was very large surface area of roof, and the auditorium spanned close to 200 meters, and the structural civil engineers, they wanted the entire roof to be allowed to, because over here in Nigeria, we have lots of pitched roofing, and we usually pitch the roof and overhang it so that the water goes. But different seasons, we have a season which lasts for what we call the wet season, which comes to another roughly 6 months. So the engineers were all out in water. But then a colleague of mine who was in attendance with me at the same meeting pointed out that we could collect the water and use it for some other uses on the ground. And the civil engineer said, but we have ample. Why do we need to collect it? And why have it will deface the building? But I said, no, we shouldn't think like that. We shouldn't think it will deface the building, but we will lose the natural potential of harvesting the water and reusing it during the dry season. So you have ample rainfall now. You want to let all the water go. During the dry season, you go buy water from 2 states or 3 states away. You transport the water all the way, and that is how you will survive for 6 months. So what I'm trying to say is, wherever you are, try first of all to understand the principles that can make your building green. Let us move away from the theoretical greening to the practical greening, especially where we have some challenges, some peculiarities compared to other parts of the world. And summary and recommendations. Climate change has become our reality as human beings today. We all know this. There's no point overemphasizing that our climate is changing. Every architect today, every member of the built industry, as a matter of fact, in one way or another, must have come across this point. The climate is changing, and it is what we can do is to help in our own little way. We cannot do, one person cannot do it all, but in our own little way, in our own drawing boards, drawing tables, when you are making your next design, think about how can this design open up to its environment? How can it incorporate the ecosystem? How can it not shut itself away from the ecosystem? And then also remember that urbanization and technological advancement continue to encourage high-rise developments. Yes, the high-rise building typology has come to stay. That is a fact, because experts have projected that more and more people will continue to move in search of greener land. As advanced as we maintain this in this part of the world, advanced countries, most advanced land, running out of land. So we must understand that high-rise developments have come to stay. And if that is the case, we must begin to understand how not to do boxes in the name of high-rise development. We must make our high-rise buildings, our skyscrapers, if we may, to be eco-friendly, to be bioclimatic. We should be living high-rise to be the natural on research further, which is very important, because if you do not know it, you cannot implement. And we are usually a sum total of what we know. You know that you learn every day. So it's up to us to do more research in this field. Personally, I've also chosen a research interest in this area because I know that we need to find out more about this building psychology. We need to find out how it behaves, what happens when you leave nature, when you increase your elevation in height. How do you, is there any particular, at what height is it possible for us to do passive cooling? At what height does it become impossible? These are the research areas that you can invest into and find out and using electricity, elevators, everything came about by research. And whoever does more research leads the rest. That is why America seems to be leading the world, because they do not relent on research. And also the government encourages researchers. Very important. If you ever find your government position, please make for research and make sure that it is not pocketed by people who are not researchers. Make sure it gets into the right hands, because I can imagine if I get a grant, for instance, to do a research, how I will make sure that my findings go global. So that's a very important factor. We must invest in research into the socio-economic dynamics and the natural variables that influence and affect the high-rise buildings. Then human comfort and environmental conservation should be top priority while at this. So I want to believe that this short discussion has been enough to strike up in you some interest into researching this building typology as an architect. I wouldn't, where one would say, oh, but in my immediate environment, we don't have too many skyscrapers, so why waste my time? It's not a waste of time. You can actually move to a place where there are more high-rise buildings with which you can do your research. And when you are done, you can publish your help also. So I'm going to, if it is allowed, I don't know. And maybe questions, I'll take a few questions as well. Thank you very much.
Thank you so much, sir. You really opened a new event in front of us. Generally, we think skyscrapers are just like you said, just tall blocks, vertical developments. But yeah, you did tell us there has to be more sensibility in building skyscrapers. So that was like a good insight all of us have got. I'm sure all the students are inspired to do more research into that area. And sir, can we take a few questions now from the audience?
Yeah, I'll be glad to take questions.
Uh, so, audience, all the participants can post their question in the chat box, and I can read out to Sir. So, one of the questions, like from my side, what are the challenges
Okay.
that what are the challenges that we face while doing skyscrapers, bio skyscrapers in a country like India or in a country like Nigeria, where we are still developing? How is it accepted, and what are the challenges that come in the way?
Okay. Like I mentioned earlier, challenge that we over in Africa, Nigeria, as in particular, have when face when to explore this biology is that technical know-how. Mostly, we depend on experts, and that is a challenge because if more and more people know about the principles, they are trained. The formal training is required. Experience is also required. So this is a challenge, and it's a very huge one because again, you talk about technological advancements. Even though we are all aware of the technologies that make skyscrapers possible, expensive upfront to them. Again, we can say we still have land. We haven't started facing the challenge of urban land crunch, which has happened to the urban centers in America, which has led them sometimes. Most times, the high rises we see, the high rise buildings we see coming up in these western parts of the world, it's not only just because they want to do that. They are pushed to do this because they don't have land to expand horizontally. But over here, we can still afford to expand horizontally for now, for now. But I know that in the next century, at most, we will also get to that point where we will need more and more and more taller buildings in order to accommodate the people. These are a few challenges, apart from the other ones which we already.
Thank you, sir. That very well answers our question, where you say that we have to be aware of where we are heading to. Yeah, economics, technology, everything comes into it. Thank you, sir, for your answer. And there's another question, which is very similar to what I already asked. What are the future challenges high-rise building with the high-rise building? I guess you've already answered that.
Already going to include the social dynamics because when suppose picture a future where humanity lives mostly in the skies, so it's going to affect our social lives. Suppose other things are equal, or suppose other things are okay, other things being equal, our social lives are going to in one way or another because again we are going to need more sky restaurant, sky or pitches in the sky because I mean maybe the ground is completely taken. You can't do sporting activities. You cannot socialize anymore on the street level. So we take it all up, and I envisage that there are going to be serious social implications, which we must all consider together and forecast so that we can tackle them when they arise.
Thank you, sir. So we'll slowly start defying the gravity and will be more above the earth. That's very interesting. We have another question. High-rise building in technology, uh, challenge and climate change challenge. So I guess the participant is trying to ask what are the challenges with the climate change and high-rise building technology.
Okay. If I understand that question correctly, I think the participant is asking what will happen to the weather elements as we continue to go higher and higher into the sky. Are we going to get to a point where oxygen will thin out and we'll have breathing issues or whatever? So that is the essence of current research going on. Like I said, I am currently interested in doing a research to find out how exactly, at what height exactly, if possible, does it become impossible to imbibe passive ventilation system? At what height? If we find that out, we can base our future designs on that singular information and improve or adapt to such circumstances. However, I do not see a future where high-rise buildings are going to grow too much taller beyond where we've reached now. I think more research is going to go into the social and economic dynamics. I don't think we're going to have buildings topping into the troposphere beyond where it will be impractical and insane to live. But again, we know that science has brought us a lot of insane things. So let us all continue doing our research and continue finding out better ways to improve this psychology.
Thank you, sir. There's another question. Possible
Okay.
to follow all the principles in designing high-rise buildings and also try to save the cost to a reasonable extent.
Sorry, can you say that again?
Is it possible to follow all the principles in designing high-rise buildings and also try to save cost to a reasonable extent?
Okay, if you say possible, I will answer you by saying, try your best. Your best. That is the essence of the rating system. We know that there are circumstantial conditions that may inhibit you at some point or at another from imbibing all in the real sense of all. But according to how much practice try it.
Thank you, sir. The other one is, while designing a high rise, how do we overcome the rules and regulations, the policies?
Overcome the rules and regulations while designing high-rise. I don't really understand what you mean by overcome. I think you should be trying to obey the rules and regulations that will be stipulated by your local development authorities, because they will be based on research findings. And once the researchers have postulated the theories, the government will imbibe this as policies. And once these policies are there, it is for all to obey and to stick by.
Mm-hmm. There's another question, a very interesting question, I would say. In a country like India, can we build a skyscraper by using vernacular materials without depending on high technology based materials?
Okay. Well, again, you can try to use vernacular materials, but these all are subject to testing. testing and testing, because as it stands now, with technology that enables, that powers skyscrapers may not exactly be vernacular. And if you try to use vernacular materials, they may or may not behave in a stable manner when you go to such heights where wind pressures and atmospheric humidity are not the same. So this is another subject for further research, and the only way to find out is to find out. So we can try this. In your next project, if you get a commission to do a high-rise building, you can try this, and then you can do post-occupancy analysis. If it works out, then you will follow. If it doesn't work out, then you will publish and say, this has been tried, it didn't work, then we can try. We can stick to the conventional materials for constructing high-rise, or we can continue developing alternative materials.
Thank you, sir. That was an interesting interaction session that we had here. Now, I would like to request architect Yoga Priya ma'am, who's the faculty coordinator, to speak a few words.
Yeah, thank you, Kosi, for joining with us today for this session. Thank you so much. Am I audible, Kosi?
It's a pleasure. Yeah, very well. I can hear you.
Yeah, I think the thesis students who have joined with this session with us today would have got an idea how to go with it. They will have an idea about the case study selection and how the building has to go with the climatic conditions and other things. Thank you so much for giving this insight, Kosi.
It's a pleasure. Thank you for
Pooja,
your
you can, yeah.
Thank you.
Pooja, yeah.
Yes, I now request our co-convener, our HOD, Professor Architect Ashok Kumar sir, to render a vote of thanks.
Yeah, I'm audible?
Yes, sir, you are.
Yeah. It's a great pleasure to have you, Kosi, today. We actually we were 2 days back. We were expected. We attended. Unfortunately, the connection was very bad. Anyhow, it is a very pleasure that you are extensively talked today, and more than 1 hour. Your presentation was very amazing, and you elaborately described different case studies. From other parts of the world, all the bioclimatic and bioblic high-rise buildings. It was a very extensive case study. It is like a movie you come into our screen now. So it is a very extensive descriptions about the bioclimatic skyscrapers today. We are very thankful to you, Architect Kosi. Really, Kosi Emmanuel, it's really very pleasure. On behalf of SRM Seed, Ramapuram campus, faculty, students, we thank you for your valuable time and experience and expertise you have on this high-rise buildings. On this our virtual mode of symposium conducted hashtag 2020. Our heartfelt thanks to our Ramapuram management, Honorable Chairman and Director, Dean, for giving us this support, encouragement to conduct these online webinars. Really having you as one of the partner for conducting this webinar. Really, we are happy to have you today. We thank you, our coordinators, moderators, technical team, and our students who are all involved directly, indirectly for conducting this webinar. We thank you once again. We thank all the participants. Of course, most of them are viewing in the YouTube now and later also. All the participants in India and abroad, your friends, our friends, architect friends, faculties, and other parts of India. We thank you one and all present here. We thank you for being continuous support to SRM Seed. We thank Architect Koshi Emmanuel for being with us today. Thank you very much.
Thank you very
Thank
much.
you.
Thank you. It's a pleasure, sir. It's a pleasure. Thanks for everyone who participated. It's our honor to be with you. Thank you.
Yes, thank you.
Thank you, sir. A sincere thanks to all the participants who have joined us today. Thank you to the technical team, digital team, moderation team, registration team for helping us conduct this webinar efficiently. We would like to thank our convener, Vice Principal Architect Lokesh sir, for this constant support and guidance, and our co-convener, Professor Architect Ashok Kumar, for this opportunity. Thank you so much for joining us. Thank you, Kosi sir, for your time.
Thank you. And thank you.
Yeah, thank you, Kosi. All the best for your research.
Thank you, ma'am.
Thank
You too.
Thank you. Yeah, thank you.